Now, Dr. Bo Kirkwood.
Complexity a little bit, and then we're going to turn our attention to what's called the teleologic argument. And the teleologic argument we've already touched on a little bit, but it's the argument of purpose and design. The universe, our world, our bodies, everything biologic seems to be very well designed, and there seems to be purpose for it. And we're going to look at that in some detail, but we're going to go fast. I'll give you a fair warning tonight. This is going to be a pretty rapid thing we're going to do, because I'm going to try to get through with this tonight, and we have quite a few slides. Just by show of hands, I'll do it this way. Who has heard of irreducible complexity? Excuse me. Okay, so there's a few that haven't. So I'm not going to spend a lot of detail on this. It's been around for a while. Michael Behe wrote his iconic book called Darwin's Black Box in 1996. Michael Behe is a biochemist. The concept of irreducible complexity, quite frankly, is really so simple that it kind of surprises me that it took to 1996 for someone to think about it and write about it. But Behe produced this book. It was very well received, even by the scientific community, for at least having some questions that evolutionists couldn't answer, or at least would have a hard time answering. And that book now, what's the math there, 25 years old, thereabouts? And there's still not a lot of good lessons, good explanations for it, 23, 24 years old. So what is irreducible complexity? First of all, it's an answer to this. This was from Darwin. This is from Origin on the Species, his book that was written in 1859, which started all the rigmarole as far as it's concerned with evolution. And that is, Darwin said, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successful slight modifications, my theory would absolutely break down. I want to point out there, he doesn't say organism, it says organ, and that's accurate. And so we're not looking at necessarily organs here, we're going to be looking at things that occur within the organism, or organs. And so if you could show, Darwin said, if you could demonstrate that if those organs or processes could not have occurred in a simple but stratified manner, in other words, successful manner, then his theory would break down. Well, it's easy to see that you can't. So Michael Behe come up with this concept, irreducible complexity. So irreducible complexity is a system composed of several well-matched interacting parts that contribute to the basic function, where the removal of any one of the parts caused the system to effectively cease functioning. That's kind of a long definition of it, but basically if you remove one part, then that particular function of that organ or biochemical reaction would not work. And that's in fact what he sees. And what Behe used was to illustrate this concept was something called a mousetrap. What's the purpose of a mousetrap? As Behe would put it, it's to enable a mouse. That's the euphemistic way of saying it. You want to enable that mouse. And there's not too many components of a mousetrap, are there? But if you took any one of those components away, it wouldn't work. You got to have everything. You got to have the spring, you got to have the hammer, you got to have the platform, you have to have all those things that are pictured there for a mousetrap to work. And if you were to remove any one of those, then you no longer have a non-functioning mousetrap. So what does evolution say? Now, evolution doesn't explain the existence of mousetraps or mice traps, whatever, but it's the same concept. But the deal is, these would have to develop all on their own in order for you to get a mousetrap. And so there's several of these, and again, most of you know what irreducible complexity is, and I'm just going to give a few examples, one in particular, and that's the clotting cascade. Clotting cascade is how your body is able to clot. Now, if you were not able to form a blood clot in your body when you got cut, you would be dead. You know, you think about it. If you put a hole in the bottom of a carton of milk, what happens to that milk? It all runs out. But if you were to put a hole in me or you, unless I have a clot, unless it's a major injury, yeah, if you were to puncture the femoral artery, you might be in trouble. But otherwise, you were to puncture your body with a knife, generally speaking, your body's going to make a clot and you're going to not die because the clot's going to form and the bleeding's going to stop. Well, the clotting cascade is very complex. There's at least 12 different clotting factors that are necessary for the body to clot properly. Any one of those factors, if it wasn't functioning properly, would cause the death of the organism. And it's not just the clotting factors. You also need vitamin K. You also need platelets. You also need calcium. It's a very complex thing. So the evolutionist has to explain, and they all have to occur in sequence. It's very rapid, occurs in sequence. The evolutionist has to explain how the organism survived to get to that final point. How did that occur? If you only got to factor 2 or 3 or 4 or 5 or 6, you're still bleeding to death. And yet, evolutionists have that explanation. I hope I'm making myself clear on that, but you have to get to that end result, evolutionary, for the organism to survive. And there's no good explanation for that. Doesn't make sense, does it? That's irreducible complexity. Not only that, the story's even more complex because, as I'm sure you know too, you don't want to overdo it when you form a clot, do you? Well, what happens if you clot too easily? Well, you get a pulmonary embolism or deep venous thrombosis that could cause a pulmonary embolism, and it's not good for you. So the body, as soon as it turns on the clotting mechanism, has to turn it off again. And it's really complex the way this occurs, and evolution does not have a good explanation for how you would get to that end point without bleeding to death first. You see the same thing in vision, and what Behe looked at was biochemical reactions. We understand the structural things when it comes to vision. You have the lens, and you have the iris, and you have the optic nerve. Those are big structures. But biochemically what goes on in vision is really complex. And vision doesn't occur if any one of those biochemical reactions is stopped. This gyrase, which is an enzyme that occurs in DNA, and it has 3,000 amino acids. It doesn't occur if you remove one of those amino acids. Behe looked at the flagella too. I look at, and Behe didn't look at this, I look at it in my book, The Evolution of Delusion. If you read that, we talk in there a little bit about the endocrine system. What's the endocrine system? Well, I'm going to use the thyroid as an easy example. For your thyroid to function properly, you have to have messages that come from the hypothalamus to the pituitary gland to the thyroid. If all you had were your thyroid working and you had no feedback mechanism for the thyroid to shut off, you would have Graves' disease. Then Graves' disease is a bad disease, and if it's bad enough, you can actually die from it. Same thing would happen if you didn't have anything to turn it on. Well, what's the use of the pituitary gland if there's no thyroid to work on to begin with? And the thyroid can't function without the pituitary gland. It's all a sequence of feedback. It's a feedback mechanism. How would evolution explain the production of a pituitary gland if there wasn't a thyroid gland to begin with? And if all you had was a thyroid gland, you wouldn't survive it. And that's true of all the feedback mechanisms in the endocrine system. So irreducible complexity refutes evolution. It refutes evolution. And I've looked at the arguments the evolutionists have against irreducible complexity, and once again it's been like 23 years and there's still no good ones. They're not out there. They don't have a good explanation for irreducible complexity. Any comments or questions on irreducible complexity? It's a simple explanation, but it still holds true. All right, let's look at the teleologic arguments. This is one that we probably use more than anything to try to refute evolution. It's what the Bible even uses in Romans when it talks about looking at the creation of God and how that proves the existence of God. And our universe shouts design. We've looked at this in some detail, so we won't spend a lot there. Life is exquisitely designed. I've already just pointed out a few things to show that. The biologic world is just full of examples, and that's what we're going to spend the rest of our time looking at, are some of these examples. To me, they're profound. They may not be as profound to you, but to me they are. They boggle the imagination as to how they could have possibly come about by pure random chance. Because once again, for evolution to occur, everything has to be by pure random chance, or it can't occur. The materialist says that. There cannot be any intelligence behind it. There can't be any design. Because if there is a design implication, that implies a creator. There's a great book. I think Jerry's read this book. I gave it to him. It's Dr. Marcus Eberlein. He's a chemist from the University of Campinas in Brazil. He's a PhD, and I think it's biochemistry that his PhD is in. He wrote a book called Foresight, and he looks at a lot of these. We're not going to go through his entire book, so don't have time for that. I picked a few of the highlights of his book, and he says how the chemistry of life reveals planning and purpose. And he's part of the intelligent design community. And he looked, and some of these I've never seen before, and if you've been in my classes, you haven't seen them either, because this book just came out this year. And he looked at the Anammox bacteria. And I'll be honest, I'd never heard of the Anammox bacteria until I read his book. But it turns out it's a pretty important bacteria, because it's responsible for the production of probably 50% of the nitrogen that's in the atmosphere. And if you don't know anything about that, if nitrogen wasn't in the atmosphere, we wouldn't be here. It's pretty important. And so it contributes, like I say, up to 50% of fixed nitrogen in our atmosphere. And that is absolutely essential for life. That little bacteria does that. How does it do that? I'm not going to go into great detail here, because that misses the point, I think. But it uses a chemical called hydrazine. It's an inorganic chemical. Hydrazine is almost like rocket fuel to this bacteria. Hydrazine left alone would actually kill the bacteria. And yet the bacteria needs this hydrazine to produce this nitrogen. And we're definitely not going to go into detail on this slide, but I just want to show you schematically what happens there. It fixes the nitrogen through nitrate reductase, then it uses this hydrazine synthase to produce the hydrogen, and it excretes this nitrogen, and it excretes this nitrogen through the wall of the bacteria. The deal is, though, hydrazine is very toxic to this bacteria, and its production can actually kill the bacteria. So it begs the question, why would this bacteria want to incorporate this inorganic chemical that's basically like rocket fuel that would kill itself to produce nitrogen that's beneficial to you and us? I don't know. It begs the question. And so Dr. Eberlein says, what I basically just said, why would a proto-Anammox bacterium, which had previously not used hydrazine and survived just fine without it, according to the evolutionist, risk its life to evolve the ability to produce and store hydrazine before it would do any good? It really does boggle the imagination. And yet, once again, we need this little bacteria. It sounds a little bit like, if you remember years ago, the bombardier beetle. Yes, the bombardier beetle. And that was, it stored this chemical that would destroy itself. It's a little bit like that. So Anammox uses rocket science to make life on Earth possible and sustainable. It shouts purpose and design. Then you got something he talks about in his book, The Venus Flytrap. I'd never thought about this either. But the Venus flytrap is not an animal. It's a plant. Okay, but it acts like an animal, doesn't it? And according to the evolutionist, it had to evolve to get to where it's at, to be able to digest this fly. This picture shows the fly. When the fly gets on the Venus flytrap, the leaves open, and then as soon as it gets inside, it shuts real quick to destroy the fly. In essence, the Venus flytrap becomes a carnivore. Didn't have to be. It was doing fine, according to evolutionists, without being a carnivore. So that begs the question once again, why would it do it? And here's the thing. No one to date knows how and can give a really valid explanation for how the Venus flytrap evolved. They just don't know. But it's a very synchronized, using mechanical receptors to open on contact, rapidly close, and digest matter. And it works in perfect synchrony to do that. And there's no good evolutionary explanation for it. It has animal-like skills. So you have this plant that had to develop these animal-like skills. Now, it eventually uses the nutrients from that fly to survive. That's true. But how did it get that way? And why would a plant ever want to become a carnivore when it was doing just fine without doing that? He also looked in the book, Dr. Eberlein does, at migrating birds. We've all seen migrating birds. They're doing it right now. And they migrate literally hundreds of miles, thousands of miles, tens of thousands of miles. And up until recently, nobody really knew how they did that. Now we say, well, it's instinct. But there's actually a mechanism that they do, and that is they can use the magnetic field of the earth. They can literally, a bird, these migrating birds, can actually see the magnetic field of the earth, and they use that to migrate with. And they actually use a chemical, and this chemical is called cytochromes. And this is really amazing how this works. They use quantum entanglement to do this. Just totally amazing. How would a bird evolve using quantum entanglement? And do you know what quantum entanglement is? I certainly didn't before this, or I had a very, very vague idea. But it uses the concept of electrons that have interacted in the past, not current. It's an amazing thing. This is from David Kaiser that Eberlein quotes. Tickle one particle here by measuring one of its properties, its position, its momentum, or its spin, and the partner should dance instantaneously no matter how far away that second particle has traveled. That's quantum entanglement. And quantum physics boggles your imagination to begin with. So we're not going to get into the detail of that. But this occurs in about 100 microseconds. It's very, very fast. And this again is from Eberlein. If a bird navigates through the Earth's magnetic field using radical pairs and quantum entanglement, it's implausible to suppose that such an amazing ability evolved one small functional step at a time. We're back to irreducible complexity. How did that develop until it was fully functional? How did this quantum entanglement and these chemicals occur that allow the birds to migrate, which are necessary for their life, for them to survive? How did that occur one step at a time? It boggles the imagination. Now, we're past Dr. Eberlein's book now. We're going to get into some other ideas. And Craig Thomas, who's a gospel preacher up in Indiana, I believe, he's a PhD in microbiology. He looks at instinct. And this comes from his little paper called Does God Exist? And we're going to look at this in a little bit of detail. And this one I had never heard of before. Now, I cannot explain these instincts, and neither can evolutionists for that matter. But there are some very peculiar things amongst the animal world that, again, kind of defy our own explanation. It seems to be inherent in them. They have some sort of instinct. They have some sort of sixth sense, if you will. Who recalls the tsunami of 2004 in Indonesia? It was horrible, horrible, horrible. Over 200,000 people were killed in that tsunami. And you can go and look on YouTube and see some of the pictures of what was going on when all this occurred from this earthquake that occurred offshore. The animals seemed to know something was going on before it happened. And the only explanation I have for that is instinct. The elephants were found, or looking back on it, were trumpeting, and they were breaking their chains, and they were running to higher ground. Again, before the water was coming in, this happened. You had breeding flamingos that sought a higher ground. They had to go to a high ground. They seemed to know that something was happening. Some of the fishermen that were out in the ocean at the time said that the dolphins were acting extremely peculiar before this occurred, before this tsunami occurred. And so I only brought that up because, again, there's no good evolutionary explanation for something like that. There's no good explanation for anything of the instincts when you look at that. I'm going to give a quote in just a minute from Josh Gertler. But here's some other examples. Sea turtles. I don't know a lot about sea turtles, but if you watch any video on sea turtles or watch any of the shows that you can watch on these animals and so forth, these sea turtles come from the sea. They wash on shore, they lay their eggs in the sand, and then they leave. And then what happens? Well, the turtles are hatched, and then what do the turtles do? They go right back out to sea. Nobody is showing them how to do that. There's no mama turtle around to do that. That's not the way it works. These turtles just know to do this. They have instinct to do that. The gray whales that migrate 6,200 miles, how do they know to do that? These are instincts. We could go on and on and on about these instincts that there is no good evolutionary reason for. Because this is the problem. If animals had to develop instincts, they would have died off long before they were able to carry out functions necessary for life. Functions that can only be accomplished through instinct. They would have died out long before that if they had to develop instincts to survive. A few years ago, A lot of you were in this class. I think we showed this in the auditorium on a Friday night, Saturday night. Can't remember exactly what night it was, but I showed when we were doing our class on evolution this movie picture called March of the Penguins. Morgan Freeman, if you recall, was the narrator for that. Amazing what these penguins would do. They come on shore in Antarctica. They march 70 miles, sometimes longer, to get to the place where they're going to find their mate. They're going to mate with the other penguin. Eventually, an egg is going to be hatched. Now, we're talking about in temperatures that are extremely low. The egg will not survive if left unattended. And so it shows this dance that the male and female penguin would do, if you recall that movie, where they gently move the egg from one penguin to the other as the other penguin leaves to go get food and come back and take over the job for that other penguin. And they do this until that penguin is hatched. And then eventually, of course, if it survives the winter and they keep it, it doesn't take long. If that egg gets away from the penguin, the egg is dead and the penguin is not hatched. But after that, then they have to feed the penguin. So the mother and the father, the male and the female penguins, go back and forth to the sea, bring food back, regurgitate it into the hatchling's mouth so it can survive. Also that down the road, as the penguin matures, it can make the march the other way to get to the ocean and dive into the ocean and then come back later on in its life and do the same thing. That's instinct. And there is no good explanation, evolutionary explanation for that. God talks a little bit about this in Job, at least I think. Job has his questions. God points out there's a lot of things, Job, you know nothing about. And I picked a few verses here. I didn't go through the whole chapter on chapter 39 there, but the first 4 verses, God is talking to Job. Do you know the time when the wild goats bear young? Or can you mark when the deer gives birth? Can you number the months that they fulfill? Or do you know the time when they bear young? They bow down, they bring forth their young, they deliver their offspring, their young ones are healthy, they grow strong with grain, and they depart and do not return to them. Sounds a lot like the March of the Penguins in a way, doesn't it? And Job uses this, or God uses this to Job on other things as well, such as the ox, the ostrich, the horse, the hawk, and the eagle. Now, this is the important thing to know, and I made this comment a few weeks ago. And that is, the point is that man cannot discover how these things occur. I'm sure man now has understood when the ox has what the gestation period is of the ox and so forth. And it wasn't that we can't discover that. Just like this, the migrating birds. It's amazing that they were able to discover quantum entanglement. How did that happen? I don't know the scientist that was able to do that. But the point isn't that we can't understand these things. It's understanding how they occurred randomly through evolutionary processes, because God's given mankind the ability to understand these things. And we don't know it all. We don't know it all yet. There's a lot of things that occur in the animal kingdom that we don't know how they work. When I was going through my medical school program, it was amazing to me, especially in physiology, how we would always get to the bottom line. It would always be mechanism not fully understood. Mechanism not fully understood. Yeah, we'd always get to the bottom. How does energy occur through ATP? Well, the actual mechanism is not fully understood. It may be fully understood at some time, but it wasn't at least 40 years ago when I was in medical school. So these things, it's amazing. So it's only by design that they occur, not through evolution. And I hope I've pointed that out. Now we're going to spend a few more minutes here talking about other things that are somewhat similar. They're not really necessarily irreducible complexity, but things that make you think about purpose. And Michael Denton has recently written a book called The Wonder of Water, and you've probably never thought that much about water. Okay? It turns out, now, when we're looking for life on another planet, which we're trying to do, I don't think we're going to find it, but they say what are they always looking for? Water. If there's water, there can be life. I think everybody understands, at least life as we know it, cannot function unless there is water around. Water is extremely important, and it's actually a wonderful molecule because it sort of defies logic, the things that it does. If the H2O molecule, the hydrogen bonds between the H2O molecules weren't sticky, you wouldn't have liquid water. It could not exist. Those hydrogen bombs, and there's no other molecule that acts like water does. It's very, very unique to water. So the molecule itself is an extraordinary molecule. There are at least 73 anomalous properties of water, of which, and this is from the London South Bank University, I got this from Dr. Denton's book, of which at least 13 properties are needful for life to occur. And it would appear that it's very unlikely that this would have all occurred simply by chance, and that just by the lottery system we happen to be here because of these 13 properties that we see in water. We're not going to look at all 13 properties, but I want to look at just a few. And one of the most important things about water is that it's the only molecule that can exist in 3 stages at ambient temperatures. There's no other molecule that can do that. Now, ambient temperatures aren't necessarily 98 degrees or 72 degrees, but ambient temperatures all the way from the Arctic to the tropics. And so what are the 3 molecules how it exists? Of course, it's solid, that's ice. It's liquid, that's water. And it's water vapor, which is in the sky, obviously. We need all 3 of those components of water for life to exist. If all we had was just one of them, life could not exist. And if we didn't have this, we would not have what's referred to as the hydrological or water cycle. Now, you probably remember this from your science, but basically, water evaporates into the sky, forms clouds, rains come down, you got water evaporating in the Antarctic. All that is part of the big hydrological or water cycle. It's absolutely imperative for plant life to exist. Hence, it's also absolutely imperative for animal life to exist, because animal life depends on plant life, does it not? We have to have that. And then without this hydrological cycle, life would not exist, and yet we wouldn't have this hydrological cycle if you didn't have all 3 phases of water. And this is my little schematic of it. There's a lot of other things we could put in there, but through the hydrologic cycle and plate tectonics, you have rock erosion. What's important about rock erosion? That's how you get soil, and that's how you get minerals that go into the water that eventually finds its way into the plants. The water has exactly the right tension and the right viscosity. And if it didn't, you wouldn't have plant life. Why is that? Because water actually, well, you know this, you plant a seed in the ground and it forms roots. How does water get from the root to the leaves? Well, it's because it ascends through its through its perfect viscosity. It goes up the roots. That's how it's done. And if it couldn't do that, you wouldn't have photosynthesis, and you wouldn't have wood or plants. You wouldn't have photosynthesis by itself if you didn't have water. Every biological reaction that occurs either in plants or in animals water is needed. And if you don't believe that, quit drinking. Yeah, you got to have water. So atmospheric water also, you hear about the greenhouse effect. Everybody heard how bad the greenhouse effect. Let me tell you, if we didn't have a greenhouse effect, we'd be in big trouble, because we'd be nothing but ice. And we wouldn't have plants to live on. So you need, now greenhouses can be too much greenhouse and we will burn up. I understand that. But water is absolutely necessary to have this greenhouse effect. And if you didn't have that greenhouse effect, we would be a frozen world. And so it's absolutely essential that we have that. And I think it's interesting too that when we go to the book of Genesis, what do we read in Genesis chapter 1, verse 6? God said, "Let there be a firmament between the midst of the waters, and let it divide the waters from the waters." And we see that water was the first thing we see in Genesis chapter verse 2, is we see the waters of the earth. And there was only water at the beginning, if you remember that. So God saw the importance of water and talks about the water and talks about that hydrological cycle there, right there in Genesis. And God called the firmament heaven. Now, Michael Denton's book, it's a 250-page book. We're not going through all that. If you have an interest, you ought to get that book and read about it. It is a little bit complex. There's a lot of science in it, so be ready for that if you get it. But water is something that really defies evolutionary thought as well. Last thing we're going to look at is we're going to look at something, and I've known about this for a while. I've never presented this in my class before, but after looking at it, I thought it, at the very least, is interesting. And you may not see the relationship between it and design or purpose. I sort of do. And so I just find that it's very interesting. And it's been around a long time. There was a mathematician, this is from John Clayton's book, Dandy Designs Very Well, and the title of his article, John Clayton's article, is The Mathematician and His Magic Ratio. And some of you are going to know about this. But there's a 27-year-old mathematician, his name was, I pronounce it Fibonacci. I may be saying it wrong, but Fibonacci. He was a 13th century mathematician, young guy, as you can tell. Of course, a lot of science is done early on in age. Einstein was in his early 20s when he came up with the theory of relativity. But this guy, he looked at the breeding of rabbits, and he looked at the ratio of rabbits and the pairs of rabbits. And he saw a definite progression, not only in rabbits, but in a large part of the biologic world. He saw this progression. And it was always this: 1 pair, 2 pair, 3 pair, 5, 8, 21, 34, 55, 89, 144, 233. Who in this class is real smart and can tell me what's peculiar about that ratio? David?
Well, if you take like 1 and 2, add those together, you get 3. Add 2 and 3, you get 5, and so on and so forth.
You get a star. Yeah, that's right. That is the ratio. It's been called the golden ratio. And the corollary to that is exactly still the same thing. But if you were to divide the small number into the bigger number, you're always going to get this ratio. So divide each number by the next highest number, and it's always going to be 0.618. It's the same thing that David just said, but it's said a different way. Say, oh, big deal. What does that mean? So it's been called the golden mean. You see it a lot in architecture and art. That ratio seems to be the most pleasing ratio that we have when we're looking at art. And there's something called the pleasing rectangle. And again, this is that ratio. That rectangle is the rectangle that if you and I look at, that's the one we like the best. If it was any skinnier, it wouldn't look right. If it was any shorter, it would look more like a square. But that ratio is that 1 to 618 ratio, and it's referred to as the pleasing rectangle. And so they came up with this thing. David, have you seen this? This Hambridge Whirling squares, anybody else? Well, what they did there, and it's kind of hard, maybe hard to see up there, but first you got that, all these are pleasing triangles, pleasing rectangles. First you got the big rectangle, and then you cut that one kind of at a third on the right, and you got another rectangle. And then you cut that one that way across, and you have another rectangle, and you do another rectangle to the left of it. It goes on and on. And it could actually go to infinity if you wanted it to do that. And then you take a line and you go through the 2/3 portion of that rectangle, excuse me, and you get this curve. That's what you get. They call it Hambridge Whirling squares. And you can look up Fibonacci, and he had the same idea, and you get this curve. So what? It turns out that nearly every living creature and many non-living constructions of God fit this spiral containing the Fibonacci ratio. That's what's kind of interesting. Again, you can take with this and do with it whatever you want to. I still find it very interesting. It seems to shout purpose. But you look at a lot of things in nature, nearly every living creature, and many non-living constructions of God fit this spiral containing this Fibonacci ratio. And I'm going to show you, I'm going to give you, this could go on and on and on. But if you look at the spiraling galaxies, the spiral in the galaxy, it will have that 0.618 ratio. Meteorite crater curve, same thing. Nautilus shells. You look at the shell of Nautilus. I think we have a picture coming up in just a minute that shows this. It's that same ratio. It's that same curve. Guess what? Even the semicircular canals inside your inner ear have that same ratio. Isn't this amazing stuff? I think it is. The keys on the piano, it's that ratio. It's 5 to 8. It's the same ratio. Why is that? Because that's what's pleasing to our ear. Comet tails. Even the surf that's in the water has this same ratio. Elephant tusk, parrot beaks, pine cones, pineapple seeds, etc., show this ratio. And these are just a few of those examples we just read off. Up at the top left, you have a spiraling galaxy. Not all galaxies are spiral, by the way. Our Milky Way galaxy is. But if you look at the curves of that galaxy, it's that same ratio. It's that 0.618 ratio. If you look at the curve of the ram's horn on the left, it is that same 0.618 ratio. Look at the curve of the beak on that parrot. I don't know how to measure this stuff. It takes someone smarter than me, so I figure they know what they're doing. But it's that same ratio. The curve of the surf, even the actual surf, when you go look at it at the beach, that curve that's in that surf, it's the same ratio. And then on the far right is that nautilus shell. It has the same ratio. So, I think it's interesting. It seems to point to design to me. It may not to you, but it does to me. Is there an atheist explanation for why so many things in nature fit this ratio? Well, they say trial and error did it. Just trial and error. Just, in other words, almost coincidence and just trial and error. And that ratio seems to be a very functioning ratio. Doesn't really work, though. First of all, it doesn't explain the non-living examples. How does trial and error explain the swirling spirals of a galaxy? It doesn't. That's not even biologic, is it? Or the swirls of the surf. Those are non-living things. So trial and error doesn't explain it. Also, really, these don't really provide much of a survival advantage. You know, the curves of the horns on the ram and the curve of the beak, not a real good survival advantage. So it doesn't. Atheists have trouble with that because it really doesn't. If it's evolutionary, it should have a survival advantage, and it doesn't. And the other thing is, it's seen even in the most rudimentary forms of life. You will see these ratios. So that calls Sir James Jean to call God is a mathematician. Appreciate your attention.